Aloha, students. Today we are going to take on some of the more difficult multiplication. We're going to step up our multiplication. And I think by the end of this, you might be surprised how these tiles help you do some pretty crazy things that maybe in the past you weren't really able to do. Um, so, so I'm going to show two ways to model this because for some of you, it's going to click differently. This first model could be kind of a quick way, but I don't know if it's going to help you with some of the later stuff. We'll see. We'll see. But what I'm going to do is I'm going to model what's inside that parentheses first, just like PEMDAS, parentheses first, right? And I'm going to have it horizontal, like all together like this, and you'll see why, just because, well, you'll see. All right, so there is 2x plus 3 right there. Now, I want four of those. So what I can do is just highlight this and go 1, 2, 3, 4. And there it is. There it is. I have 8 x's, and I have 4 times 3. I have 12. So I have 12 plus 12. Okay. But let's change this for a second. Let's change it to 5 times 2x plus 3. And obviously, you guys know what to do here. You could just make another row of that, right? But there's something I want to show you. So we have 2x plus 3. Dang, I should have erased all of that. Whatever. 2x plus 3. All right. Now, what we can also do is, again, just keep this as a heading. Like the same way I would, the same way I would like put 5 here and then like 4 here as just headings to tell me how big the rectangle is, to tell me what's in that rectangle when I try to find area. Okay, so this way again is the way when we're going to use headings. And the advantage to this is it just gets a lot easier when we get more complicated multiplication going on. So this is probably the way to stay, in my opinion. So watch how we do this. We're gonna go with the heading route. So we'll have 1, 2, 3, 4, 5. And you could do space or not. It's up to you. Okay, so now we have one row of x. So we'll just kind of lay it down in here, right? And then another row of x. 1 times x is x. 1 times x is x. Then 1 times 1 is 1. So we're having one of that. In this row, we're having one of everything that's in that heading. We're not counting that, right? That's just a heading, just like the 5, right? All right, and you can see what's happening. And at this point, I will highlight that and use the copy button to go like that. And now, again, this is really important. Please don't miss this. I am only counting the stuff inside. It's like the inner triangle right here. Whereas, again, this and this are the headings, just like 4 and 5 are the headings right there. It's just like instead of writing the number, I'm using the models to show what would be in that heading, and then using that to get what I want in here. So the answer is 1, 2, 3, 4, 5 times 2 is 10x plus 15. Sweet. All right. So now we're going to do one together in your packet. All right, let's do 4 times 3x minus 5. Okay, so we're going to work with our parentheses first. We're going to try to go lateral, horizontal, across. And at this point, we're just going to look at this as a heading. Okay, 1, 2, 3, 4, 5. Okay, so there's my heading on top. And then I'm going to have 4 rows of those. And these, again, are just the headings for each row, right? 1, 1, 1, 1, 1 makes 4. And so here we have x times 1, and we can represent that by the shape that will fit in there, right there, right? And I might, I might just, this might be a good idea for you too. I might draw a line if I can with my mouse. A line right there to delineate, like those don't count. Those are just headings. All right. So let's fill this, fill that in. We fill in one row. Boom, like that. And then 1, 2, 3, 4, 5. And we'll just come in here like this. And we'll copy it because it just so happens that those are all ones. There we go. Fill it in. And our answer is 1, 2, 3, 4, 5 times 3 is 15. No, 4. Dang, I almost made the same mistake. 1, 2, 3, 4 times 3 is 12. 12x. And then over here we have 1, 2, 3, 4, 5, 4 rows of it. That's negative 20. All right, make sure you draw that. Do it on the mat and draw it on your paper. All right, guys, so in your packet, I'm going to give you a few more problems like this, and I want you to do them on the mats. And I'm only going to ask you to draw probably just one of them, just to make sure I can see you know what you're doing. Or you can just show me it on a mat. You're welcome to, for one of the problems to just, hey, look, Kalama, here's how I do it. And that'll be great. That'll help me feel comfortable. You know what's going on. Whoo-wee! Look at this. Look at this. But you guys have seen this before. This is distributed property. This is something called FOIL. But you don't have to remember any of that because you have these interactive tiles and it will help. Before we get started though, I want to explain that this is like, remember in our last problems, we would see something like 4 of these, 4 of this amount, right? It's the same thing here. It's just it's not 4, it's some amount within that parentheses. It's kind of like doing this. It's kind of like doing, oh, I don't need, hold on. It's kind of like doing this, except for we know a little more details. Like this is the question mark right here, right? But we have some details in there. I just want to give you a chance to see what that is. Okay, so guys, what this essentially means is one of these is our headings going across. So we'll use 2x plus 2. It doesn't matter which one is your length and which one is your width, but we'll make 2x plus 2 our length, and then we'll make 3x. Well, you know what? Actually, I'm gonna switch that because 3x is longer and I have more room there. So we're gonna say 3x, and then 4 is on top. 2, 3, 4. And then on the width, 2x plus 2. There we go. All right. Now we just fill in the spaces. Guys, an x, if we have x length, x width, or whatever, vice versa, then we have x squared. So I'm going to come in here and fill those in. Looks like we have more down here, down here, down here. Now, guys, what's cool about this is I'm just thinking what piece would fill this in? What piece would fill this in? Watch. This won't because look, it doesn't line up correctly with the 1, right? But you know what will? X times 1 would be like this. Ah, look at that. Look at that. All right. And then down here, I have 1x, and then another 1x, and another one, and so on and so forth. They just fit. And just as a quick reminder, we are only looking at, at this portion right here. Oh, it looks like I forgot to fill in some. What's going to go there? Let's see. Well, it's 1 times 1, which is just 1, right? Or that's the only shape that's going to fit there. All right, so I'll go like this, Boom, boom, boom. Yeah. And so I'm looking what's in here, right? And I have 6x squareds, and then I have 6x's down here, 10, 14. So, and I have 14 x's, and I have these 8 const constants. Okay, that's what we call them, just 8. If there's no variable, we just call them constants. It stays constant. Dude, look at that. Look at that. That's pretty good stuff. That's pretty complicated stuff. Okay, so how we're going to model this is I need more room to go across. So I'm going to do 5x up here, 1, 2, 3, 4, 5. Then I'm going to have 4 negatives, negative 4. Okay, 2, 3, 4. And going down, I'm showing 3. Oh, that should be negative 3x. So let me highlight that and flip it. So I'll flip those 3, flip. All right. So negative 3x plus 2, 5x minus 4. All right. Okay, so then what are we going to do? We know that one of these blocks will go with negative x times x. We know it'll be one of these blocks. But the question is, like, is it positive or negative? Well, you guys already know a negative times a positive is a negative. But I want you to think of it this way. Wherever I see a negative, it is oppositing something, right? So here's x times negative x. So I need to be oppositing it. It's not, this was positive. I need to opposite it. So I'm going to flip it, all right? And the same thing is going to be true all the way down. Wherever I have x times negative x, I'm going to have those blocks. So I can fill those all in right here. Now, let's look in this area right here. I have it in red, but I maybe should have done black. Okay, this right here, this area right here is negative 1 of a negative x, meaning the opposite of a negative x, which would be a positive x, right? So I'm going to come up here and grab a positive x, right? The opposite of a negative x is x. And that'll be the same for the next column, the next column, and the next column. Oh, and even down here. There we go. All right, now, what does this 1 mean? It means like I just want one of the x's. So I'll come in here and fill those out. Okay, all right. So then what about this area? Dude, I do not know why it does that. It's like, so what is going to fit in this area right here, right? Well, this one right here, actually. So we have the opposite of 1. So we have 1 being multiplied by the opposite of 1, which would give us an opposite, right? So what we have to do is get the opposite there, which is negative. Boom, 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 boom. Now, we're going to total everything up, starting with our x squareds. We're not going to count these. These are just headers, right? These on top and on the side. But we have, in each column, we have 3, and we have 1, 2, 3, 4, 5 columns. So we have 15 x squareds. And then we have 10 x's here, and then we have 12 there. So that's 22 x's. Now I go in this order: x squared, then x's, and then my constants. I have I have 8 negatives.